Hello, I'm Prateek NILAJAGI, currently in third year Electronics and Communication Engineering, Dayanand Sagar College of Engineering, Bengaluru. Today I'm giving a presentation on microcontroller-based washing machine simulation using PICSimLab. Yeah. First, I would like to thank Emergy for providing this internship opportunity for us. We have learned a lot in this internship. So this is our internship flow. First, we learned about C programming, everything about C programming and how to integrate it into embedded systems. Then we learned about embedded system, what are the types of it, what are the memories of it, and all. Then we started interfacing some components provided on the board, like LEDs, buzzers, fans, etc. Then we integrated all the components and made our project washing machine. So these are the components we used. First, we used MPLAB X IDE. This is the integrated development environment which we use to write our program. This is a free uh, free platform software environment which is specifically designed for developing our controllers or embedded systems, and which it also targets about developing microchips and microcontrollers and digital communication controllers. Then we used PICSimLab. This is a software used for simulation. Uh, This is the software we used for our simulating washing machine. This is a free software which uh, we, specifically developed for quick microcontrollers. It allows testing, debugging, and integrating the various elements of the hardware without hardware virtually. Then we used Quick Genius Board. It has the inbuilt uh, components like CLCD screen or fan, buzzer, tactile switches, LEDs, etc. We have a PIC 16 F8778 microcontroller integrated in this. So is that microcontroller to program our project. Then about the PIC 16 F778 microcontroller, it is a microcontroller developed by Microchip technology. It is a 8-bit microcontroller, and then it has a very rich set of features and peripherals. Uh, the core of the microcontroller has 14 KB of flash memory, and it has 368 bytes of RAM, 256 bytes of EEPROM, then much more features. Then one of the key strengths of PIC16F877A is it is diverse array of peripherals. Like we can use that for a wide range of applications. Then if we come to communication protocols, it supports UART, SPI, and I2C timers, PWM models, and much more. Then it is a power efficient microcontroller. It has both performance and energy consumption, ample consumption. Then it is low power operation makes it an ideal choice for our application. Yeah, next, next, yeah, C programming. C programming we started with keywords. Uh, Keywords in programming are the previously like predefined set of phrases which we cannot use for other operations except what it is developed for. The keywords include many kinds like data types, modifiers, qualifiers, loops, jump, etc. etc. Data types come the data we use data types as also as uh, defining at the beginning variables. Some of the examples are char, int, float, double. We use char to define the characters, int to develop, int to define integers, float to define decimals, and double to define long decimals. Then we have modifiers like signed, unsigned, short, and long, which is based on the memory allocation provided for these data types. Uh, these signed, unsigned, short, long modifiers are used before these data types. Then you use qualifiers like const to volatile, etc. Mm, Then we have loops, for loop, while loop, do while loop. These are while loops are we use to iterate a specific program for a specific number of times. Then we have jump, state jump like go to break and continue, where we use these uh, statements to break out of the loop or continue in the loop or break out of the iteration also. Then we have decision making keywords like if, else, which case, and default. We use if and else for like if we have only two conditions. If we use which conditions we if we have like multiple choices to choose from. Then we come to number systems. We C programming supports all four types of number systems like decimal, octal, hexadecimal, and binary. We mostly use hexadecimal, and mm, then we come to yeah. So conditional statements. What are conditional statements means? Uh, we use them for decision making. Like we have two inputs, and we need to choose one from that uh, input. We use conditional constructs like they are if else, for, switch case, etc. Then we have arrays. Arrays are like single, one-dimensional or two-dimensional array of data. Then we have pointers. Pointers are nothing but the address to the specific memory location. Rather than using the uh, variable present in memory location, we often use pointers. There are many types. We can initialize pointers. Then we have functions. Basic C programming, we use multiple functions. And then, like if we have to do a specific task, then we cannot write the same code in the same function in the main function again and again. Instead of that, we use the function. Function is defined uh, at the top of the main function. Then we can like uh, define what it does in again somewhere else. These functions we define once and we use multiple times in main program. And then let's go about embedded system. Embedded systems is a combination of hardware and software. It is designed to do a specific task. So embedded systems are domain specific. That means it is developed to do a single kind of task. At the heart of embedded system is a microcontroller or a microprocessor. Uh, it is engineered to meet the specific requirements of the target application. These processors can come in various architectures like 8-bit, 16-bit, and 32-bit. In addition to the processor, embedded systems also comprise the peripherals and sensors to interact with the physical world and respond with real time. These peripherals can include interfaces like UART, SPI, and I2C for data exchange, timers for precise timing control, analog to digital converters for interfacing with analog sensors, and digital to analog converters for generating to analog signals. We typically use digital to analog converters uh, for our applications like fans and all. ADCs are used mainly in sensors to convert the environmental analog data to digital radio wave format. Then embedded systems are often incorporated with firmware or software which is called our program. The software is usually developed using specialized programming languages and tools tailored to target microcontroller architecture. So memory memories of embedded systems are classified into multiple types like RAM, ROM, PROM, EEPROM, EEPROM, and flash memory. Random access memory, it is usually a low storage or low capacity memory which we use in real time computation of embedded system. It has usually low capacity, or because it only does it is a because it is a volatile memory. It doesn't store the data after the power is gone. So after power is gone, we store the data in read-only memory, which is cannot be accessed easily. Here we store the programs for the embedded system and constant values and all. Random access memory works with real-time input and output exchange and real-time processing, while the ROM memory stores the data and uh, it is used for longer purposes. Then in read-only memory, we have multiple types like mask ROM, PROM, EEPROM, EEPROM, and flash memory. Masked ROM refers programmable read-only memory is a ROM which is not programmed previously by the manufacturer. Programmable read-only memory is received by the customer, then it is programmed by the customer, and it is also called as one-time programmable memory because it uses thin wires as fuses. Once the memory is programmed, we cannot reprogram it because the once the fuses are burnt, we cannot reconnect them. Then erasable programmable read-only memory. We can erase the. It uses like something called as floating bit memory storage. We can program it once, and uh, we can erase it using specialized techniques. Some techniques involve using UV light to make the electrons shift back where they were. And electrically erasable programmable read-only memory, it has access to each bit. We can erase and write each bit of the read-only memory. While the flash memory, we can also use UV light to erase the memory, but we cannot access the bit by bit. We need to access it like as a complete memory. See, so in the component interfacing, we for our project we used first we interfaced LED. LED was connected to port. LED was connected to port P as shown in PIC Genius datasheet. Port V of uh, PIC microcontroller. Then we have tactile switches. So there are total six tactile switches in the board. These usually are connected as pull-up circuit. Pull-up circuit meaning normally the microcontroller is connected to power source, and when we use the tactile switch, it it like so. The pull-up circuit means it is normally connected. mm, It is normally connected to the high power. Then when we press the switch, it connects to the ground. And the tactile switches are named as RV02, RV1, RV2, RV3, RV4, and RV5, RV6. Here we are using RV5 and RV4 mode. There are three timers in this microcontroller, naming timer 1, timer 2, and timer 1, and timer 2. After the program is completed, like after the switcher user input is taken, we need to run the washing machine. So to simulate the running of washing machine, we are using a fan here. And after the program is complete, to alert the user about the completion of program, we use buzzer. So first we are in project integration where we have programmed all these CLCD features, timers, and all CLCD display, timers, buzzer, and fan previously. So we're integrating all of those to create our washing machine project. First, power on screen. Here, in the power on screen, we should display power. Press key 5 to power on the washing machine, and we need to constantly read the key 5. Once the key 5 will be pressed, we need to go to next display, that is washing program display. It is this power on screen is a simple programming just to use CLCD.print, and we can write this. Next is washing machine. washing program screen. Here we provide different options for the user, like daily, heavy, delicates, and all. Depending on the choices of clothes, user will select the option here, like daily clothes or heavy clothes or delicates. Then we need to constantly uh, monitor the status of key 3 here, because if the key 3 is pressed long enough, then we should take it as an input, or we should take it as selected for this particular option. And also if it is pressed for a shorter time, then we need to move the options up and down. So this was a bit complex, but we did it. Next, water level screen. Similar to this washing program, we have provided different options for water level of the washing machine, because some clothes require uh, little water and some clothes require much more water. So here also we use the water level. First we enter water level at the first array, first row. Then we had here also we have to constantly monitor the status of switch. If it is pressed long enough, then we need to take it as an input of the current option. But if it is pressed for a shorter time of time, then we will switch the options up and down. Next, we once the user selects the some water level option, then we go to start stop screen. Here, user can start the washing machine or stop the washing machine. Once the user starts the washing machine, we we display what the program user has selected, then what time it takes for the washing machine to complete the program. Here, for example, here the user has selected delicates, then the time taken for it is 20 seconds. Usually the washing machines use 26 minutes, like in minutes, but here we are using only seconds to speed up the process. Here, the user has selected delicates, and the time for it is 26 seconds. Here, 0 minutes and 26 seconds. Then the program starts running. Function, whatever the function that program has user has selected will be displayed here. Then the time will be constantly down counting here. Then if we need to pause in pause in between the program, then we can press the switch 6, or after the pausing, if we need to start the program again, we can press switch 5 here. If we press the pause, this will be displayed everything, fan and buzzer. Fan will be stopped running, and this program will display. And again, door open status. So if the door is open, we need to turn on the buzzer and say it is closed. Please close, and display the status of door as open. Now coming to the simulation of project. Yeah, this is the program we wrote. This is main.h file. Sorry. Okay. This is the main.c file. I'm sorry. This is other project. Let me open my project. Yeah. Here is the okay. Here is my program, including the main.h and xe.h port compiler and digital keypad, timers, LCD, and all. Then this is the program we wrote along with classes. Okay. Now let's clean and build this. Okay, clean successful, no rest. Okay, build successful. Now let's go to simulation. Okay, this is the ingenious microcontroller board. Let's load this hex file. Here is your hex file. Okay, this is a start screen. When we first press the key 5, like switch 5, then it should display as powering on washing machine, and then go to the like daily program. Sorry, was that? So when we press the switch 5, it should display as uh, powering on washing machine. Then it should go to washing program display screen. Here I'm pressing the key 5, switch 5. Yeah, powering on washing machine, and it goes to washing program screen. We can move uh, up and below the options using switch for here, delicates, whites, stain wash, eco cottons, woolens, and bedsheet. Here I will be using daily, so I'll press and hold this switch 4 to select it. Okay, now we have gone to water level screen. Here we can select the water amount of water we need. We can go switch between options using this switch 4 again. Yeah, it is switching medium, high, max. Yeah, I am selecting auto here. I should go to start stop screen. Yeah, so this is the start stop screen. If we want to go to start the program, it will go to start. But if we want to stop the program, it again goes to uh, washing program screen. So I'm gonna start it here by pressing switch 5. Yeah, this is the daily program selected. This is the time taken. Here it is down counting the time. This is fan running. If I want to pause it, I will select switch 6 here. The fan is paused, timer is paused. Then if I want to start it again, I'll press again switch 5. It starts again. But if it, to show the door status open, okay, I press the door status open for hardware not switch. It says uh, please close the door. Let me start it again. Okay, again that is running, and after once it completes, it gives out a buzzer sound. Yeah. So this is our program. This is the washing machine project we have implemented in class in internship. So thank you. This is all about it. Thank you.